All right, here we are. Your last Algebra 2 video. Try not to cry. This is 23.2 normal distribution. So we've talked about probability. We're talking about how things are distributed. So there's a handful of things that I want to show you. First of all, this is an example of what they call a normal curve. And I don't know if you've ever heard that vocabulary in real life, but basically it means that most things fall in the middle. Most people, most data points, whatever, fall in the middle. And that there's a few on the high end and a few on the low end. So if I give you like a quick little example here. The normal curve, thinking about grades, right? A C is what people are most likely to get. So what this means is that in the middle here, most people are likely to get a C. There's kind of equal parts that get a B or get a D, but very few people get A's in general, and very few people get F's. And not talking about like the, socio-science or whatever behind that, but in general, that's what a normal curve says, that most people should fall in the middle and that fewer people fall on either extreme. There is an example of something called, so I would label that this is normal. Did not spell that right, normal. There is something called left skewed and right skewed, and basically it means where kind of the tail end is. So for example, this would be an example of something that it's a little bit backwards of what you would think. This is what is called right skewed. And that just means that there's this tail end on the right side and that the middle has been pushed over, which is weird, to the left. And then conversely, there's something called left skewed. And so it means that there's this tail end on the left side. And so it still looks kind of normal. It's just got a tail end on one side or the other. So let's look at some percentages, because the question today is how do you find percents of data, and specifically how do you find probabilities associated with normal distributions? That's what we're doing, is using normal distributions to find probability. So there's a few different ways to memorize this, but this is what you need to memorize. There's this 68, 95, 99.7 rule. And what it means is that 68% of the data falls within one standard deviation of the mean. Now remember that mean means average, so I'm going to zoom in here so you can see this. Mean, they use this little mu for mean, and it's just the average, which you get if you add them all together and divide by the number. So 68% fall within that, which means that's one standard deviation to the left and to the right. And then there's another 95%, two standard deviations to the left and to the right. So if you go two standard deviations, which is just a measurement, in either direction, you're going to hit 95% of the people. And then there's three standard deviations, which is going to give you 99.7. So some of you may memorize it that way and be able to kind of calculate what the percentages are within that. I think what most people do is to memorize this curve right here. So this is the percentages that fall within each of these ranges. So for example, you've got your mean, your average here in the middle. And if we go one step in either direction, that's 34% to the left and 34% to the right. If we add that same standard deviation, which I haven't really explained to you, that's what this is. It's like an O with a little kind of tail on the top. Each standard deviation you go adds a different percent. So some of you are going to maybe remember 34 and then 13.5. and 2.35, and this 0.15 at the end. If you add all of these percentages together, the ones that I have circled will give you 50%, because this is the top 50%. Or if you add the entire curve together, you should get 100%, because that's 100% of the people. All right, so let's look at actually how we use this to solve a problem about probability. All right, so I'm going to go ahead and read our problem. It says the average time is normally distributed with a mean arrival time of, and I can't actually read that because of where this is on my screen, and a standard deviation of 15 minutes. Okay, so if we go ahead and draw out the curve, that's going to be the easiest way to make sense of these problems, is to draw this out. Wow, that was terrible. All right, try that again. There we go. All right, it says the mean, the average there in the middle, is at 430. I cheated while I paused the video. All right, and then it says standard deviation is 15 minutes. So what we need to do is count up 15 minutes to get all the standard deviations. So I'm going to count up by 15. That's going to be at 4:45. And then up by 15 again. That's going to be at 5 o'clock. And remember, this should go, I think, 3 standard deviations up. 5 o'clock and then 5:15. All right, and then I'm going to go 3 standard deviations down. That's 4:15. 4 o'clock, and 3:45. And then we need to go ahead and fill in percentages. All right, so all I'm doing is going off of that chart I gave myself just a minute ago. So this is 34%. All right, and then the next one is 13.5%. All right. Okay, and then we have 2.35% and 0.15% at the end. So I'm going to fill those in also. So now once you have that memorized and you can add and subtract, this is literally just a matter of counting. So the first thing says, what's the probability that a plane is going to land after 4:45? So that's this section of the curve, after 4:45. So we're just going to add together 13.5 plus 2.35 plus 0.15. And whatever you get there, that's your final probability or your percentage. Question 7 then, find the between 4:15 and 5 p.m. Okay, so between 4:15 and 5 p.m., you just look at what part of the curve that is. All right, so that's 34 plus 34 plus 13.5. All right, you see what we're doing here? So the other one's going to give you a range also between 3:45 and 4:30. So that's 3:45 to 4:30. So you're going to add those three values together. And you need to add these for your notes so you have a good example. The last one, it says by 4:45, which means 4:45 is the latest time. And we're looking at everything before that. So I'm going to add all the way back to this 0.15, all the way up to that 34. All right. So there you go. That's how you use normal distributions to figure out probabilities. And that's our last video. I love you all. See you later.